Whenever economists study the economy, they rarely examine one variable in isolation. Instead, they ask questions such as: does higher GDP growth tend to occur alongside higher investment? Does inflation move together with unemployment? Do interest rates rise when inflation rises? All of these questions concern one fundamental idea. How are two variables related? The first statistical tool that measures this relationship is called covariance. The second, and much more useful measure, is called correlation. By the end of this lesson you will understand what covariance measures, why correlation improves upon covariance, how both measures are calculated, how to interpret positive, negative, and zero correlation, and why correlation is one of the most widely used statistics in economics, finance, and data science. Throughout this lesson we shall work with an assumed economy. Suppose economists observe the annual GDP growth rate together with the annual inflation rate over 10 consecutive years. These numbers are simulated solely for demonstration. They do not represent any actual country. Looking at the table, we immediately notice a pattern. Years with higher GDP growth also tend to have higher inflation. But visual inspection is subjective. We require a numerical measure that tells us how strongly these variables move together. Covariance provides the first answer. Before performing any calculations, economists almost always construct a scatter plot. Each point represents one observation. If the cloud of points slopes upward, the variables tend to move together. If it slopes downward, one variable increases while the other decreases. If no clear pattern exists, there may be little or no linear relationship. Our scatter plot displays an upward trend. This suggests a positive linear relationship. The next question is: how can we measure this relationship numerically?
Covariance measures whether two variables move together. If both variables tend to increase together, their covariance is positive. If one variable increases while the other decreases, their covariance is negative. If no systematic linear relationship exists, their covariance is close to zero. Let x and y represent two variables with n observations. The sample covariance is computed by averaging the products of their deviations from their respective means. Here, x bar and y bar denote the sample means of x and y. Notice the structure of this formula. Each observation is compared with its mean. These differences are called deviations from the mean. If both variables are simultaneously above their means, their product is positive. If both are below their means, their product is again positive. But if one variable is above its mean while the other is below, their product becomes negative. The covariance simply averages all of these products. Mathematica returns a positive covariance, 1.21. This confirms that GDP growth and inflation generally move in the same direction. However, there is an important limitation. The magnitude of covariance depends entirely on the units of measurement. If GDP were measured differently, the covariance would also change. Therefore, its numerical value is difficult to interpret. Economists therefore prefer another statistic, correlation.
Correlation is simply a standardized version of covariance. Instead of measuring raw joint variation, it scales covariance using the variability of each variable. As a result, correlation has no units. Even better, it always lies between -1 and +1. The denominator converts covariance into a pure number. This makes correlations directly comparable, even when variables are measured in completely different units. the correlation equals 0.96. This indicates an extremely strong positive linear relationship. Notice that this number has an immediate interpretation. Unlike covariance, every correlation lies between -1 and +1. These three graphs illustrate the entire range of correlation. When every point lies exactly on an upward sloping line, the correlation equals 1. When every point lies exactly on a downward sloping line, the correlation equals -1. When the points form no clear pattern, the correlation is close to 0. Remember, however, zero correlation does not necessarily imply independence. It simply means there is no linear relationship.